Okay, 5-3. This is super simple. It's adding and subtracting polynomials. Adding and subtracting polynomials. So when we add and subtract things, what do you have to have in order to add and subtract? What has to happen? If I'm adding 2x cubed minus 5x squared.
Add like terms.
Yeah, I'm adding like terms. Now, when it says in a vertical format, what does that mean you're probably going to have to do? Yes. And a vertical format means I have to rearrange it to go like this. 2x cubed minus 5x squared plus 3x minus 9. And then I'm going to go x cubed plus 6x squared. Remember to line that up in order. This would be a vertical format. So if it says vertical format, I should see it vertically like this. Okay? And I simply add 2x cubed and x cubed together gives me 3x cubed. Negative 5x squared and 6x squared gives me x squared. 3x and nothing gives me 3x. And negative 9 and 11 should give me 3. Yes? No, 2. Maybe if I could do math, that would help. 2. Okay? And so vertically, that's how they want it done. On the next one, it says add in horizontal format. So horizontal is just keeping it like this. 3y cubed minus 2y squared minus 7y. And then we're adding to it negative 4y squared plus 2y minus 5. So this is horizontal. Negative 3y cubed, there's no y cubes, we just drop it. Negative 2y squared plus negative 4y squared is negative 6y squared. Negative 7y plus positive 2y is negative 5y. And negative 5.
If this is all we're doing, I would be so happy.
Well, sort of. This is all we're doing, but we're going to learn some special things in a minute. Okay? Subtract in a vertical format. Once again, subtracting in a vertical format looks like 3x cubed plus 2x squared minus x plus 7. And then you're going to have 8x cubed minus x squared minus 5x plus 1. When you are subtracting, do not forget that you have to distribute that negative into all portions of this. So I have 3x cubed minus 8x cubed. You get what? 3x cubed minus 8x cubed. Negative 5x cubed. I have 2x squared minus negative x squared. You get what?
Negative x.
Nope. 2x squared minus negative x squared.
3x squared.
3x squared, because you have a double negative, which is a positive. This is where people mess up the most, is when we subtract them. Negative x minus negative 5x, you get?
6x.
No, negative x minus negative 5x.
4x.
4x. 7 minus 1. Boom, there's my answer. That would be a vertical format. Now, horizontal format of this. 5z squared minus z plus 3 minus parentheses 4z squared plus 9z minus 12. What is 5z squared minus 4z? Yeah, just z squared. Negative z minus 9z. Negative 10z, good. 3 minus negative 12. 15, because a double negative is a positive. Boom, boom, boom. Okay, this is the first part, adding and subtracting. How do you feel about adding and subtracting?
I love it.
Okay, next part is multiplying vertically and horizontally. So let's say we're going to multiply vertically, okay? Multiplying negative 2y squared plus 3y minus 6 and y minus 2 vertically. This is vertically. Multiplying vertically. We're going to do it like we would multiply, let's say you have 312 times 12. We're going to multiply it the same way you would do that. So when we do this, we multiply 2 times 2, 2 times 1, 2 times 3, we put a placeholder and multiply 1 times 2, 1 times 1, 1 times 3, yes? And then we add them all together. Same concept here. So pretend these aren't connected and we say -2 times -6, what is that? 12, so you put a whole 12 right there. Okay, and because it was a negative and a negative, that means this is going to be a positive. What's -2 times 3y? -6y. -2 times -2y squared, 4y squared. Now, we have a placeholder, yes? So we put a 0. Y times -6. -6y. Y times -2y squared. Oh wait, this should be -6y
Y squared.
squared, so we gotta line it up. Right? Sorry. This should be -6y. I think I skipped something, that's what I did. Okay, and then y times -2y squared is -3y cubed.
Where's -6y squared?
Look, y times -6, -6y, y times 3y.
That should be a 3.
Oh, it'd be positive 6y squared. Oh, positive,
Great.
thank you.
She got the 6 because like she thought that.
I'm losing my mind, I'm sorry. Then we simply add these together from there. So I have -3y cubed. What is 4y squared and 3y squared added together? And then I have -6y and -6y. Should be -12y, and then I have 12 and 0, which is 12. Good. Okay? So when you're doing it vertically, I need to see your work. As in, we're doing it like we're third graders. Okay? Yes, Ellen, you're looking confused.
Wouldn't it be -2y squared?
Yeah. You know, Elle, I'm telling you, my brain, I've had a migraine since I woke up this morning. I think I'm getting a sinus infection. I am a little not clear in the head right now. Now, if we're doing it in a horizontal format, you need to set it up this way. X plus 3 times 3x squared minus 2x plus 4. What do you do when you have it set up that way? Distribute, like FOIL distribute. So x times 3x squared is 3x cubed, yes? X times -2x, -2x squared. X times 4, 4x. 3 times 3x squared, 9x squared. 3 times -2x, -6x. And 3 times 4 is, from there, what do we do? So 3x cubed. Then I have this and this. What's -2x squared and 9x squared? 7x squared. Then I have this and this. 4x and -6x. And then I have 12 left over. Boom. So depending on what format they want it in, depends on how you're showing me work. Got it? And do practice these formats. This is leading into polynomial long division. You have to be able to do this old school type of math in order to do polynomial long division, or else it's gonna be rough, okay? Now, there are special rules, and this is why we're gonna spend 2 days on this, because of these special rules that you need to memorize. There are special patterns, okay? There is a sum and difference pattern. That's a plus b times a minus b gives you a squared minus b squared. So if you have x plus 4 and x minus 4, it gives you x squared minus 16. We know that as a difference of squares, yes? So we're just unfoiling it, or using it from the FOIL version this time. It's called the sum and difference, okay? Or difference of squares. You'll see it as both. The square of a binomial, if I have a plus b squared, this is where a lot of people mess up, because you guys usually say, oh, it's a squared plus b squared. No, right? We have to actually make 2, and we have to factor it out, blah, blah, blah. Well, this is a way to cheat, okay? Square a, multiply a and b together, multiply by 2 for the center, and then square b. And then you don't have to FOIL. So if I have y plus 3 squared, This first number is y squared, the last number is 3 squared. The middle number is 3 times y times 2, 6y. Okay, because there's 2 sets of those, so you're doubling it. That's why you're multiplying that middle part by 2. That way we don't have to spend time foiling. If you can recognize these patterns, you can spend like no time doing math on some of these. And it makes it super quick. Okay? Difference of a square of a binomial, a minus b squared. Once again, you take this front part, you square it. You take the back part, you square it. And once again, you multiply these together and multiply them by 2. The only thing that's different is there's a minus sign in the middle. So 3z squared minus 5 squared means I'm taking 3 and squaring it and z and squaring it. That's how they get 9z squared. You squared both parts of that front part. The back is 5 squared, which is 25, and the middle is 5 times 3z, which is 15, negative 15z squared, times 2, negative 30z squared. Okay? These are just special patterns. If you memorize them, they make life easier, especially if you're going to go into pre-calc. Meaning you two for sure. Okay?
That's fun.
Because in pre-calc, if you can recognize this, when you're doing sine, cosine, and tangent, because they're gonna put it in this form, then you don't have to do math. And you don't wanna do math with sine, cosine, and tangent. Because it will take you forever, that's why. So if you memorize the pattern, it makes life easier, okay? The last part is called a cube of a binomial, and it's also got a pattern. So it's a plus b cubed. So watch this. This first part is a cubed, okay? There's always a power of 3 here. The second part is 3, because once again, there's 3 sets, so we're multiplying everything by 3. It's 3 times a squared times b. This power is 2, that power is 1. They always add to be 3. The fourth part is 3 times a times b squared. Once again, a power of 1, a power of 2. They always have 3 together. And then the last part is just b cubed. So if I have x plus 2 cubed, I get x cubed plus 6x squared plus 12x plus 8. And it has it for a difference of cubes too. A minus b cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed. This goes positive, negative, positive, negative. Okay, that's the only difference. P cubed minus 9p squared stop plus 27p minus 27. So, we get special ones. That first one, what do I need to change it into? Without showing any work of foiling, I can change it in my head. What would it be?
The first one.
The first one. 9t squared what?
16.
Minus 16. I don't even have to show work. Okay, 9t squared minus 16. On B, what would it be? The first, no. Thank you, Tyler. The first part, I got you, it's fine. Thank you.
Bye, Tyler.
Okay. The first part, first of all, you have 8x minus 3 squared, right? Okay. So that means if I were multiplying out, I'd have 8x minus 3 times 8x minus 3. That means, remember the pattern is like this. This part gets squared, there's a minus sign, minus something times 2 times a times b, right? Plus b squared. What's my a? 8 what? X. So what's 8x squared? 64x squared, right? Okay. So my a is 8x, my b is what? My a?
8 times 8.
Yep, so what's 3 times 8 times 2? So minus 48x plus, what's negative 3 squared? 9. That's the answer to that one, without even showing the work. This is like the one time I'm telling you not to show the work. But if you don't have the pattern memorized, then it's gonna be hard for you not to show me work. Okay, part C says PQ plus 5 cubed. Okay, remember this has 4 spots. This says a cubed, right? Plus 3a² b plus 3ab squared plus b cubed. Okay, that's the pattern. What's my a?
P,
pq.
Q,
So what does that look like then?
PQ, Q.
Both portions have to be cubed. P cubed, Q cubed. That's a mouthful. Plus, I have to do a squared times b times 3. So what would a squared be?
P squared.
Yeah, b squared, q squared, right? And what would b times 3 be? Because what's your b?
5.
And so 5 times 3 is?
15.
Boom. Now, we do 3 times a times b squared. What's b squared? Well, 25. What's 25 times 3? 75. So then you have 75 PQ, yes? And then what's my b cubed? What's 5 cubed? What? Nope, that's too big.
4.
What's 5 times 5? 25 times 5.
Oh shoot, 125.
25. And I did that without having to factor 3 times, without having to FOIL 3 times.
I think it's 75.
How did I get 75? Because you have to take b, which is 5, square it. 5 times 5 is 25. And then you have to multiply it by this 3, because there's 3 sets of these equations. And you get 75. That's how. Does that make sense?
Yeah.
Okay. So this is what we're working on today. Tomorrow I'm going to give you more problems on this. And then Friday when I'm not here, you will review for your quiz over 5.1 through 5.3, and Monday you will take it.